Okay, so to finish this example up, remember, just to refresh your memory what we were doing, we have these x's. X stands for the original data point. So all of these x's are from the data that we were given over here in example 1. So the diastolic blood pressure readings, and I just listed them in order from lowest to highest. X squared, I'm just taking the first column and squaring it. So 52 squared gives me this guy. 58 squared gives me that guy, so on and so forth. Third column here, this says x minus x bar. Remember that x bar is the mean of the sample, and we found that yesterday in our notes that we did yesterday. We found the mean was 74, so all I did was take 52 minus 74 to get this. Then 58 minus 74 to get that guy, so on and so forth, all the way down the line. This last one is simply the column before it squared. So all I'm doing here then is taking negative 22 and squaring it, negative 16 squaring it. Remember that when we square negatives, we should get positives, so don't make that mistake. So then I'm just going all the way down to get those. All right, and I can't even read my own writing here because I had to write it in between. I think that's a 14, so that's 196, and then 16 gives me 256. So the reason that I'm doing all of this is because of the formulas that are on the front here that I'm going to use. So the first formula right here is what I'm going to use first. So on that guy, it says S equals the square root of the sum of x minus x bar squared divided by n minus 1. So the real reason that I believe it's so important to do a few of these by hand is so that you understand the symbols and the way that things are grouped, in addition to understanding how we get standard deviation. So this is, think about what standard deviation says. The word deviation means vary, right? And what these columns are how much that value varies from the mean. So it's 22 below, 16 below, the same as the mean, 2 above the mean, so on and so forth. So we're taking each of those individual variations and squaring it, because that'll give us a positive number, which is what we have here. And this symbol means to sum them. That means add them all up. Now, totally fine, because I understand we've already done a lot of writing. Totally fine if you just want to write like the first few. So if I'm taking the sum of all of these, it just means add this whole column up. So if you just want to write like 484 plus 256 plus ... and then 196 plus 256 down here, that's fine. I'm going to know what you mean. You don't have to write out the entire string if you don't want to, because we know that your calculator can help you with that. N in this case, the sample size is 12, so 12 minus 1 is going to give me 11 on the bottom. So when I use this first formula and add all of those up, it is going to give me, I hope, I didn't press any buttons incorrectly, 1,440. So then I divide that by 11, and then I take the square root. So when I divided by 11, I got this guy. Remember not to round intermediately. That's going to be something that's always pretty important in math. So I got 130.90 repeating. I'm not going to like retype in square root of 130.9. I'm going to do, and you can see it on here. See, I've got this guy in my calculator. I'm just going to do second square root, second answer. to make sure I'm bringing the whole thing along. So that way I'm not going to be off by a tenth or a hundredth and wondering why. So that means that S is approximately, since our original data were whole numbers, we round to the tenths place. So that gives us 11.4. The S squared, because it's the square of this original, I really just go a step up. So it was 130.909090. So that one is 130.9 to the nearest tenth. Okay, second formula was this one. And again, these formulas are all on the front. I'm just rewriting it so we have it right where we're using it. It's n times the sum of all x squared minus the sum of all x squared. Notice the difference between this guy and this guy. Squared on the inside, squared on the outside. That means square first and add them all up. This means add them all up first and then square. And then divided by n times n minus 1. So, sum of all x squared means add this whole column up. So, sum of all x squared, I got 67,152. So, n was 12, 67,152 minus the sum of all x, and then I'm going to square that. So the sum of all x means to add all of these together, which I got 888, and then I'm going to square that, and then over 12 times 12 minus 1. So then, when I simplify, that gives me 80582. I think that's a 9, hopefully. Minus 788544 divided by 132. Then, what do you know? When I type all that in, I get the exact same thing that I got before, which should happen because these are two interchangeable formulas. So again, I don't care which one you use as long as you show me your work. Now, as I mentioned in class, you do not, please don't, do all of the ones in your homework this way by hand because I realize that's a lot of work. So in class, we had discussed which ones you were going to do by hand. And of course, now I have to look at it again. It's 6, 8, and 12. So 6, 8, and 12, I want you to use one of these two formulas. But the rest of them we're going to do in our calculator. And so I'm going to show you how to do that next. So in your calculator, if you go to Stat and Edit, just looking, I wasn't sure what data I had in here, so I'm going to clear my list. And I'm going to enter my BP readings there in my list 1. So just these X values. So 52, 58, 64, 72, 72, 74, 76, 80, 82, 88, and 90. And then I'm going to double check them to make sure I didn't mistype anything. Looks good to me. Okay, this is also a shortcut for some of your measures of center. Those ones aren't too terrible to do by hand, so I didn't really feel too bad making you do those by hand. But the standard deviation is very, very time consuming. So 3 problems in the homework where I want you to practice it. After that, you can use your graphing calculator. So what we're going to do is we're going to go to Stat after we've entered it. But this time, instead of edit, we're going to scroll right to calculate. And you're going to choose choice 1, one variable statistics. Tell it which list. See, look, mine says list 2, but my data is in list 1. So I press second 1 to change it. And then I go to calculate. And then notice some of the symbols that you have already been given. So X bar, that's my mean. Sum of all X. So what do you know? That's this that would go in this formula. Next one, sum of all X squared. That would also go in this formula. So can make it easier to get your work done there. But these are the next ones that you really want. SX, right here, is your sample standard deviation. Sigma X, you would only use if this were a population, which this is not. It's a sample, so please remember to use SX. N gives us the number of data pieces. The rest of what we have in this we'll discuss in the next section, but I did want to show you that shortcut so that you don't have to do all of that by hand each time. So 6, 8, 12 by hand. The rest you can go ahead and use your calculator to help you out and to just write down your answers. All right, so part C. Mrs. Thomas's brothers-in-law had diastolic BP readings of 56 and 94 respectively. Are either of these values significant? So this goes back to our range rule of thumb for identifying significant values. So values are not significant if they're within 2 standard deviations of the mean. So this says mu and sigma, but we can replace mu and sigma with X bar and S when it's a sample. So in this case, we know that X bar, because we're using the same data still, was 74. We now know from this that our standard deviation is 11.4. So that means that if I take X bar minus 2S, that's going to be 2 standard deviations below the mean. So I figure out what that would be. Do my 72 minus 2 times 11.4, which gives me 51.2. For X bar plus 2S, same idea, but change the sign, I would get 96.8. So what this tells us is that values that are between 51.2 and 96.8 are not significant. Values below 51.2 are significantly low, and values above 96.8 are significantly high. So 56 is between these, so that's not significant. 94, also between these, so not significant. Now, the 94 is definitely on the high end for sure, but it's still within that range. So we would say no, because both values are within 2 standard deviations of the mean. Last one, pretend that our data is normally distributed. So again, if it's not, we're pretending that it is. 99.7% of the data would fall between what 2 values? So this is an application of the empirical rule. So over on here, it tells us right up on this line, 99.7% of the data are within 3 standard deviations of the mean. So you don't always have to draw it, but I do a lot. I know that my mean is 74, and I know that my standard deviation is 11.4, so here's 1 standard deviation on each side. So if I go up a standard deviation, that means I'm taking 74 and adding 11.4, so 85.4. If I add 11.5 again, So that'd be 96.8. This is 2 standard deviations above the mean. So 3 standard deviations above the mean would be to add 11.4 for a third time, which is 108.2. If I do the same thing in the other direction, and I go 74 minus 11.4, that gives me 62.6. Subtract 11.4 again, gives me 51.2. So that's this again, this guy is my mean. So 1, 2 standard deviations below, 3 standard deviations below would give me 39.8. The reason why I like to draw it out is because they usually ask more than one question for the same data. So if I have all the numbers here, it helps me answer all of them. So I know 99.7% of the data would fall within 3 standard deviations, which 3 standard deviations is here and here. So that means they fall between this number and this number. So 99.7% between 39.8 and 108.2. Then it says what percent would fall between 51.2 and 85.4. So if I look, from here to here is 1 standard deviation. And so 1 standard deviation, according to what's written here, covers 68%. So those 2 parts, if I shade them differently, cover 68%. And then I just need to add in this part right here. Now, 95% fall within 2 standard deviations. To go from 68 to 95 is an increase of 27. So that means that half of that, because I'm only doing a second standard deviation here, half of that 27 is what is represented here. So plus 27 over 2. If you just want to write out the 13.5, that's fine also. And that would give you 81.5%. Notice that on the picture, they did actually give you real to the hundredths place values of how much exactly it is. You know, we say 68.95. This is a little more than 68. But you don't have to have those values memorized. If you know the 68, 95, 99.7, then you know enough. Okay, really sorry that took extra time, but hopefully now you should be able to get everything done. Again, calculator for everything except 6, 8, and 12, which those ones you do need to have work. And that's it. Have a great weekend.